Assalamualaikum and hi everyone. This video we continue finding probability using the Poisson table. Before we start solve this question, we look the Poisson table first. For Poisson table, we have value for lambda, this row for lambda, and value for r, this column value for r. We have r at left side and r at right side. We look example for number 1. If x with lambda 5.5, first find a px greater than or equals to 5. Please note that Poisson table we use sign greater than or equals only, same as binomial table. We just use sign greater than or equal only. So question A, we have px greater than or equals to 5. We have sign greater equal, so we can direct find from the table. We look our table. Lambda is 5.5 and r equals to 5. So we find lambda 5.5. Okay, first page doesn't have lambda 5.5. We go next page. We find lambda 5.5. So we have here lambda 5.5, and our question x greater than or equals to 5. So our r is 5. So our value is 0.6425. So we copy answer here 0.6425. Question B, px less than or equals to 5. Less than or equals to 5, we can read from the table. So we need to change less than equal become greater than equal. So we use 1 minus px greater than or equals to 6. Since we want 0 until 5, so we minus 6 and above. Then we check table, lambda 5.5 and r equals to 6. Lambda 5.5 and r equals to 6. So we have answer 0.4711. So we minus 0.4711. Then we solve, we get answer 0.5289. Question C, we have px equals to 5. Px equals to 5, we need to change in sign greater than equal. So we use px greater than or equals to 5. We minus with px greater than or equals to 6. To find 5 only, so we need to take 5 and above minus with 6 and above. We have value for 5, 0.6425. We minus with 6, 0.4711. Then we calculate, we get answer 0.1714. Next question, we want to find probability from 3 to 8. 3 include, 8 not include. Means that we want to find 3, 4, 5, 6 and 7. To find 3 until 7, so we use px greater than or equals to 3. We minus with px greater than or equals to 8. We want 3 until 7 only, so we minus 8 and above. Then we find from table px greater than or equals to 3, lambda 5.5 and r is 3. We have 0.9116, and x greater than or equals to 8, we have 0.1905. So we have two value, we copy 0.9916 for 3 and 8 is 0.1905. Then we minus, then we get answer 0.8011. Okay, we finish example for number 1. Now we continue question number 2. The number of breakdowns in a particular machine occurs at a rate of 2.5 per month. Assuming that the number of breakdowns follows Poisson distribution, find the probability that. Before we start solve, we determine the lambda first. We have Poisson distribution, so we write x with Poisson, and lambda is 2.5 per month. Our lambda is for 1 month. Okay, we look at question A. More than 3 breakdowns occur in a particular month. More than 3. So Px greater than 3. Occur in a particular month. So we use lambda 2.5. Greater than 3, we can read table. So we need to change Px greater than or equals to 4. Greater than 3 means we start from 4. 3 not include. Okay, now we check our table. Lambda 2.5 and R equals to 4. Okay, we find here our lambda 2.5 and R 4. So we have answer 0.2424. We copy. Answer is 0.2424. Okay, next question B. Less than 10 breakdowns occur in 3 months period. Okay, now 2.5 lambda for 1 month. Now we want to find in 3 months. So our lambda change to 2.5 times 3. So we have lambda equals to 7.5. Okay, question asks to find less than 10 breakdowns. So we want to find Px less than 10. Less than 10, we can read the table. So we need to change. We want 0 until 9. So we minus 10 and above. So we check table. Lambda 7.5 and R equals to 10. So we have here lambda 7.5 and R equals to 10. So our answer is 0.2236. So we copy here 0.2236. Then we minus, we get answer 0.7764. And next question C. Exactly 3 breakdowns occur in 2 months. 2.5 for 1 month. Now we want to find in 2 months. So our lambda is 2.5 times 2. So our lambda equals to 5. Then question asks to find exactly 3. Exactly means our symbol is equal. Equals to 3. To find equals to 3, we take Px greater than or equals to 3. We minus with Px greater than or equals to 4. We take 3 minus with 4 and above. Then we get 3 only. Okay, now we find from table lambda 5 and R3 and 4. So we have here lambda 5.0 and R is 3, 4. So we have 0.8753 and 0.7350. So 0.8753 we minus with 0.7350. Then we minus, we get answer 0.1403. Okay, now we continue next question, number 3. A life insurance salesman sells on the average 3 life insurance policies per week. By using Poisson distribution, calculate the probability that in a given week he will sell. Question A, some policies. Some policies bermaksud dia ada jual juga life insurance tu, tapi tak tahu berapa lah. Cuma dia bagi tahu dia ada jual juga. So bila ada jual, means that we want to find Px greater than or equals to 1. Maksudnya dia ada jual juga polisi tu. Maybe ada 1, maybe ada 2 ataupun seterusnya. So we use sign greater than equal. And before we solve, we write x with Poisson. Lambda is 3. Lambda 3 for 1 week. Okay. Now we find Px greater than or equals to 1. We check from table. We find lambda 3.0 here. And our R is 1. So 1 is 0.9502. So the answer is 0.9502. 9502. Next question. B. 2 or more policies but less than 5 policies. So question B, he wants to find probability from 2 until 5. 2 or more but less. So means we want to find 2 until 5. 2 includes since we start from 2 or more. And less than 5 not include since less than only. So doesn't have equal sign. 2 until 5 means we want to find 2, 3 and 4 only. Since 5 doesn't have equal sign, so we want to find 2 until 4 only. So to find 2 until 4, we take x greater than or equals to 2, we minus with px greater than or equals to 5. Kita tolakkan dengan 5 dan ke atas, sebab 5 tu kita tak nak, kita nak 2 sampai 4 je. So 5 kita tolak. So we check table 2 and 5 for lambda equals to 3. Lambda equals to 3 and r equals to 2 and 5. We have 0.8009 for 2 and 5 is 0.1847. Then we copy these two answers. We put here 0.8009. We minus with 0.1847. Then we minus, we get answer 0.6162. Continue question C. Assuming that there are 5 working days per week, what is the probability that in a day he will sell 1 policy? Assume satu minggu ada 5 hari je. So apa kemungkinan dia jual 1 polisi dalam masa 1 hari? Biasanya seminggu ada 7 hari. So 3 lambda untuk 7 hari. Sekarang ni kita nak cari berapa lambda untuk 5 hari. So we use X with Poisson distribution 3/5. Kita nak cari dalam masa 5 hari tu berapa lambda yang dia boleh dapat. So kita akan dapat Poisson with lambda 0.6. Then question asks to find he will sell 1 policy only. So Px equals to 1. Px equals to 1, kita tak boleh baca table sebab sign dia equal. So kita kena change sign dia jadi greater equal. So x greater than or equals to 1, we minus with Px greater than or equals to 2. Kita nak 1 sahaja, that's why kita tolak 2 dan ke atas. Then we check table with new lambda 0.6 and R1 and 2. So we have lambda here 0.6. We find R equals to 1 and R equals to 2. So we have 0.4512 and 0.1219. So we copy this answer. 0.4512 we minus with 0.1219. Then we minus, we get answer 0.3293. Mean and variance of Poisson distribution. For Poisson distribution, our expected value or mean equals to lambda. And variance for Poisson also equals to lambda. We look example 5. Number 1. If x Poissonally distribute with lambda equals to 1.8, find the mean and the variance. So the mean or Ex expected is lambda 1.8 and variance also equals to 1.8. Lambda refer to mean and variance. Okay, now we finish 9.2 Poisson distribution. So to make you more understand with this subtopic, you can doing this exercise. Thank you everyone.